Hello and good morning from Pune. My name is Vidula Mhaiskar and I am talking to you from a lovely campus, IISER campus in Pune. On the occasion of Children's Day, which is on 14th November, we are airing this episode. I work in a place called Garware Balbhavan. It is of course in Pune, and it is a recreational center and playground for children. Here three main activities that we do with children at Balbhavan is play and a lot of free play. Second is music, and third is stories. Our children love to hear stories, and the special thing that they like to do is hear stories with props. Using props in storytelling just catapults storytelling to another dimension. These props help you. There are advantages in many ways. First of all, when you make these props, you kind of develop some hand skills, and while you are making these props, you also learn a lot of science and maths behind them. So today I am going to tell you some stories and a little bit of science and maths that goes along with it. I hope you enjoy listening to these stories as much as I enjoy telling them. First story that I am going to tell you is the story using newspapers, and it's a story that involves lots of caps. So I am just going to invite Tejal. Please come here, Tejal, to help me with the caps. Alright. So here goes the story. So this is a story of a small girl whose name is Tejal, of course, and then she lives in a small village in Konkan area. As you know, Konkan is very famous for its lovely mangoes and jackfruits and cashews, and the grain that grows most in Konkan is rice. So Tejal works in a small rice field, and you know how rice is sown? Small saplings are grown in a crowded area, and then they are plucked out. When they are about this big, they are plucked and they are replanted in mushy soil. So all this has to be done in rainy season. So Tejal has a cap called as an irla, which she wears on her head, and she is working in her field all the time. Now Tejal goes to school, and her school gets a newspaper. So Tejal has learnt a lot about what happens in a city. So she is very curious to go to a city and see what are the things that are happening there. So so during her holidays, she decides to go visit a city. So she packs her bags, and since it is rainy season, she also packs her irla, as it is called. The first cap is called as an irla. So she packs her irla, sits in a train, which is Konkan Railway, and comes to a nearby city, which happens to be Ratnagiri. Now Tejal has travelled a lot and she feels hungry. So she goes to a hotel, eats poha there, and asks the hotel wala ki I am new in this city, can you find me some work? The hotel wala says, good you came, my bawarchi has run away, so why don't you become a bawarchi? So Tejal gets her irla, she changes a few folds in the cap and makes a bawarchi's cap like this and starts working in the kitchen. Now Tejal is a small girl, so within a week of being a bawarchi, she's very bored. She wants to try something else. Now while she is a bawarchi, there is a grocer that comes to the hotel and selling all the groceries. So she says, let me try and become a grocer now. So she changes her cap into a grocer's cap and becomes a grocer. Again within a week, she gets tired of being a grocer. But Tejal is a very sweet talker and a very hard worker. So while she is a grocer, she earns a lot of money. So she said, what should a wealthy person do? So she has seen a saukar in her village. So she said, let me become a saukar, but a good one. So she changes her cap into a saukar's cap like this, and she becomes a money lender. Being money lender is something that Tejal just doesn't like, because you have to sit in one place and you can't run around here and there leaving your tijori. So she's very bored. So she comes outside her building and she's thinking, what should I do next? And suddenly what happens is, building next to her catches fire. So fire brigade walas come and they extinguish the fire. And then Tejal realizes, ever since I came from my village to city, I've tried out many things, but all these things were to earn money. This is my chance to help community. So she changes her cap into a fire brigade's cap like this. Fire brigade cap will always have a beak like thing at the back. This is just to protect our spinal cord from getting hurt. Now again, after a week of being into fire brigade, she wants to try something else. So while she is a fire brigade wala, she gets to meet another community helper, and that is a Havaldar, police. So she changes her cap into a police wala's cap like this and becomes a police wala. Now she has tried so many things ever since she came from her village to city. Even if she did everything for a week, she has spent 5 weeks in the city. Now she is tired. Now she said, I have had enough of city, I am going back home. If you remember, she came from her village to city in a train. Now since she lives on the coastline, she decides to take a boat. So she sits in the boat and slowly her boat is traveling to her village. Boat is a very slow mode of transportation. So after a long time, she starts seeing coconut trees on the horizon. So she said, good, now my boat will dock in an hour and I'll be able to go home. But what happens is suddenly a huge storm comes in, and along with the storm, it's like waves going, really huge waves, and her boat starts to go up and down on waves. There is a huge rock in the middle and the boat hits the rock and front part of the boat just falls off. Now the boat loses its balance and then it kind of tilts here, and the rear part of the boat also hits the rock, that also falls down. Now there's no front, no back of the boat, so boat actually tilts on its sides and falls, and this part of the boat, which is called as the bridge, also breaks down. Now there's absolutely nothing left of the boat starts to sink, and Tejal also falls in water. She knows how to swim, but it's difficult to swim in stormy waters. So, but she's not scared. She thinks for a minute, what can I do now? And suddenly she realizes that every boat has a life jacket. It's a fluorescent colored air pocket filled jacket, which if you wear, it is easier to swim and you don't drown. So she goes down to this sinking boat, finds a life jacket, wears it, and swims her way home. That is a small journey that Tejal had. Thank you very much, Tejal.
Thank you.
We are working with newspapers today. Let's see newspapers a little closer now. You know the way newspapers are made. Of course, newspapers is cellulose, and the way papers are rolled out, the cellulose fibers which are from the trees, they are aligned in some ways. So we have this very fun exercise that we do with kids. We give kids these strips of newspapers, and we ask them to just hold it on one edge and cut it into tear it into long strips like this. This is the strip normally we have in hand, and this is the strip we give children. And you will see that this one kind of strip will not be able to tear into long strips like this. This is because, this is of course a trick thing, cellulose fibers in the newspapers are oriented in a particular way. So if you tear it in the way you read a newspaper, you can hold it like this and tear it into long strips like this. But if you take a strip that is not aligned, which is 90 degrees to its alignment, and then you won't be able to tear it. So this is the first thing you can try with newspapers. Paper folding by itself is binary in nature, right? So if you fold, especially if you fold the newspaper into half. Now I'll try to fold these, the story that I just told you, the caps, these stories, and let's see a little bit of maths or geometry that you can learn while folding these caps. So this is the way we'll do it. This is my paper. The folded end is away from me and the free end is towards me. First of all, straight line is 180 degrees. If I fold the paper into half, this angle would be 90 degrees. Now I'm going to open it again and make this first fold here right up to the middle. Now what would be this angle? You would certainly say it's an obtuse angle, but how many degrees will it be? This is 90 degrees and this is half of 90 degrees, that is 45. So 90 plus 45 is 135 degrees. Now I am going to fold this again here. So now this is a 90 degrees angle. You see 90 degrees everywhere, like corners of the tables are 90 degrees, everywhere 90 degrees is very easy to find. Now from this, what are the different shapes you see here? You see two right angle triangles and a long skewed rectangle as well. So I'll just lift one paper from here and double it up like this. You don't have to remember each and every step that I'm showing you now. It's there on two websites. First is arvindguptatoys.com and then Garware Balbhavan website as well. So now this is your first cap, that is Irla. For the second cap, you need to upturn it carefully, and then from both sides you have to make a cupboard fold like this. Now you can see a square in the middle, two right angles, and 4 skewed rectangles. I'll fold 2 small ends from the bottom and fold this all up here. Now this is your Bawarchi's cap, and you can see a trapezium shaped flap here as well. Now the next step after the Bawarchi's cap would be grocer's cap. For that you fold the end down and lock it up here. Now there is very beautiful geometry here, okay. This shape is a rectangle. Now the question is, you have to fold this rectangle into a square while keeping the area same. Now let's see how we can do it. A lot of times children or us, we do it like this. Now the shape is square, but the area has halved. We don't want to do that. This why does this happen? Because the length is twice that of the breadth in this rectangle. Area of this rectangle would be length into breadth, right? So if this is 2 units and this is 1 unit, the area would be 2 units into 1, that is 2 square units. What happens when I make a square like this, which is incidentally also the step of our next cap, is that now they are 2 units here. So diagonal of this square is 2 units, this would be 1 unit and this would be 1 unit. So this will be root 2, since it's a diagonal, this would be root 2. Root 2 into root 2, the area of this square again will be 2 square units. This is how we have conserved the area. Now this step can also be made into a puzzle like this. This is a square just like this one, whose diagonal is equal to this cloth bag. The puzzle is this, that initially we put this square inside this cloth bag and we ask everybody that now how will you cover this square by this cloth bag. The way to do it is, you have to slide these 2 diagonals in the cloth bag, and slowly if you cover it, you will see that it covers this very well. Now this is the same math that goes into this cap, okay. Now the next cap to make is the grocer's cap. For this you have to fold 2 corners in, lock it up in this pocket, and your cap is ready. Now this is the first cap that is 3-dimensional and that will have some volume. How would you calculate volume of this cap? Is length into breadth. Now this will be the same because it's a square into height. Now this is the first time the cap will have some volume. Now for volumes there are many things we use. This is a fruity can that we normally use as measuring cylinders. Now the question to ask is that how would you know that you get exactly 200 ml of the drink that in this cup, in this Tetra Pak when you buy it? The first thing is that if you measure length, breadth into height into centimeters, the product has to be 200 ml. And of course this Tetra Pak has to be filled completely. Then you know that this will hold exactly 200 ml. A lot of times we don't have measuring cylinders at home, but this can be used as a very nice measuring cylinder. If you cut it into half lengthwise, this will be a 100 ml cylinder. If you cut it 1/4, then it will be a 50 ml cylinder. If you fold any paper in half, paper folding by itself is binary in nature. So let's see, suppose I have a newspaper like this. The number of folds that I am going to make is the exponent, and since I am folding papers into half, we are actually performing powers of 2. So now there are no folds in this paper, so 2 raised to 0 is 1, and this you would have just 1 paper. Suppose I fold it 1 time, so that would be 2 raised to 1, that is 2, and if you cut this, you will have 2 papers here, 2 sheets. Now this will be 2 raised to 2, that is 4. If you cut again, you will see there are 4 sheets here. 2 raised to 3 is 8. So you will have 8 papers here. 2 raised to 4 is 16. So if you cut now, you will have 16 papers here. 2 raised to 5 is 32. So you will have 32 sheets. 2 raised to 6 is 64. And 2 raised to 7 is 128. So if I cut this wad, individually, you will see that there will be 128 papers here. This is how you learn powers of 2. It's very simple. Now if I press this very well, you will see that this wad is going to be 1 centimeter thick. If I ask you a question that if 2 raised to 7, which is 128 newspaper sheets, is 1 centimeters, how thick, how high the wad will be if I fold it 42 times. First of all, it is very difficult to fold any paper beyond 7 times, but what would happen if I fold the sheet 42 times? The answer is certainly not 6 centimeters, which a lot of us guess like. It is going to be 4 lakh kilometers high. That is, it's the distance between Earth and Moon. So if you try to sit on the VAD, you would actually reach the Moon. You know, and what is the power of 2? If you fold it 43rd time, you will be back on Earth. That is the power of 2. Another example of this is also an amoeba. Suppose there is an amoeba and you put it in a box, and the amoeba doubles every minute, and the box is full of amoebas in 60 minutes. When will the box be half full? A lot of us would guess 30 minutes, but this is exponential. So the box would be half full at 59 minutes, and then at 60 minutes it would be doubled and it will fill completely. The next story is the story that I am going to tell you using a string. This is 1.5 meter long nylon string, which can be knotted easily, and the knot gets undone very easily as well. First of all, this is a loop, and I can just put my hand in and get it out. Would you like to try it? Just make a loop, put it in as if you would wash a vessel, and then get it out. This is one thing that you can try with a loop. The second thing is that let's try making a mosquito. I am just going to put the loop in my little finger, spread it across the palm and get it on my thumbs. This is it. We'll get the loop out and then tie a knot. Now suppose this is a machhar. It's a mosquito. It's going around here and there, but I don't want it to bite you, so I'm going to squash it, and the mosquito is gone. There are many things that you can do with a string. Now I'll tell you a story of a forgetful farmer. There was once a forgetful farmer, and as people in the olden times used to do, they used to tie a knot if they had to remember something. So here is a forgetful farmer who used to tie a knot after every job he did. So first thing the farmer does is he goes to his field, plows his field, comes home and ties a knot. The next thing he does is he sows the seed, comes home, ties a knot. Third thing he does is irrigates his field. So he comes home, ties a knot that I've irrigated the field. The last thing he does is applies manure. Now all the jobs are done, and within 3 or 4 months his crop is ready for harvest. But suddenly a huge fat rat comes and eats away all his crop. This is how you tell the story with a string. There are many stories that you can tell using strings, and there is a beautiful book by NBT called String Games. You should actually look it up. Now strings are loops. So this is a small loop that I have. Suppose this is a loop that is 12 units long, made into a loop, of course. What can you do with a loop is, first of all, you can make many shapes. This is a triangle, you can make a square out of it, and then you can also make a long rectangle with it. A lot of times we think that when a loop is a perimeter, as we said, when we use a perimeter, when we have a fixed perimeter, no matter what area encloses inside, it will always be the same. But that is actually not correct. Let us see. Suppose I have this loop which is 12 units long. What happens if I make it into a triangle like this? If I make it into a triangle, it's equilateral triangle, its side is going to be 4 units. So half into 4 into the height would be 6.9 centimeter squares. So if you start with a perimeter of 12 units and you make an equilateral triangle with it, the area enclosed would be 6.9 centimeter square or unit square. Suppose I make a square. The square will have, of course, the side of 3. So 3 into 3 would be 9 units square, right? So that is very different. And now if I make a rectangle, suppose whose long side is 4 and short one is 2, 4 into 2 would be 8 units square. If I make a pentagon, it is going to be 9.9 centimeters or unit square, and if I make a hexagon, it is going to be 10.38 unit square. So see, starting with the perimeter of 12, you can come up with shapes that have different areas that are enclosed. Now if you make a circle out of this loop, out of 12 unit perimeter loop circle, then the area is going to be 11.45 centimeter square. Now the area of a square is pi r square h, you can calculate. So now you will see that triangle is 6.9, square is 9, rectangle is 8, pentagon is 9.9, hexagon is 10.38, and circle is going to be 11.45. So circle is the shape which encloses maximum area for the given perimeter. That is the most important thing in a circle. That is why you see tree trunks are always going to be cylindrical, because the cross section of a cylinder is a circle. So the maximum things could be packed in a cylinder than maybe a prism or a cuboid or stuff like that. You can also check this in another way. This is again these are two different shapes that I have made using matchsticks. So now this is again 12 matchsticks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. If I make a shape like this, what would be the area of this shape? 1 square, 1, 2, 3, 4 and 5. So 5 squares would be the area of this shape that I have made using 12 matchsticks. Suppose this is again 12 matchsticks, I make it into a right angle triangle like this. What would be the area of this triangle? So the area of this right angle triangle would be half into base into height. So 3 into 2, that would be 6. So here is a shape with area 5 squares. This is the area 6 squares, and if I simply change this into this shape, I have removed 2 squares from here. So the area of this leftover part would be 4 square units. So just see that starting with same perimeter, you can make shapes that have different areas. Now I am going to tell you the story of a rainbow crow. Crow, as you know, is a black cawing bird, but a long time ago, crow was very colorful. It had beautiful, shiny, rainbow colored feathers and a beautiful singing voice. Before I tell you the story how a rainbow crow turned into black crow, let us start one science experiment. For this, we need to have a filter paper, and this is the color of the crow now. So I am going to make a small dot on the paper and then fill a glass with a little bit of water. You want to put this filter paper into the cup just so that the water level is below the dot that we have made. Now water by siphon action is going to climb up by capillary action, and along with it, it is going to take all the colors with it. Now let me tell you the story. The name of the story is Rainbow Crow. It's actually a Lenape folk tale. Lenape people lived in Delaware Valley in the USA. The crow, this is the story of course of a crow. The crow right now is black, but it was not always black. It was in beautiful colors and it could sing very well. So let me tell you this Lenape folk tale. Long time ago, suddenly there was ice age and lot of snow fell and all the animals were shivering, and they didn't know what to do. Small animals got buried under the snow, the bigger ones were shivering, and soon if nothing was done, the animals were worried that they would die. There was an owl which was very wise and old. The owl said that if you go to the heavens to the Creator and get some fire to the earth back, we will be saved. Now everybody loved this idea and they said that somebody has to go. Now who would volunteer? The owl said that I am very old and anyway I cannot see well in light, so I can't go. The turtle said that I would go, but I am very slow. The deer was very distractible and so was not dependable. So many animals just came forward, but nobody was actually willing to go to the heavens and get the fire. There was one bird, our little rainbow crow. Now this was a crow with absolutely beautiful rainbow colored feathers and a very beautiful enchanting singing voice. But he was always very helpful by nature, and he said, I would volunteer, I'll go to the Creator and get some fire back to earth. So our little lovely crow started this long and arduous journey to the heavens. He flew and flew, he got tired, but he still kept on going because he wanted to save his friends on earth. He reached the Creator. The Creator was very happy. He saw that our rainbow crow had travelled so far, took so much trouble just so that he could take the fire back and save his friends. What the Creator did was he took a long stick, he stuck it into the sun and lit the fire at the end of the stick. He gave the stick to the rainbow crow and he said that you have to go and go really quickly to the earth, and you can have your fire back. The crow started his journey, and he was actually very tired, but he still kept on going, because and the stick started getting shorter and shorter with each mile he traveled. And then eventually, when the earth was really close, the stick was very small. The heat was too much for the crow to bear, and there was a lot of soot coming out. All his rainbow feathers turned black because of the soot. The smoke strangled his voice, and he lost his singing abilities, but he still kept on coming, and eventually he came to the earth, and then he delivered the fire. The animal lit the fire, the snows were melted, the animals were warm, and all the earth and the animals were saved. This is the story of Rainbow Crow. But the crow sat in the corner, and he was very sad because he lost his beautiful colors and singing voice. But the Creator was very happy because of his selfless service. So you know what the Creator told the crow? He said that your feathers are black, but I'll make them shiny. And anybody who would see that feather in the sun will always see the rainbow colors in your feathers. And so the crow was very happy. Now, as you can see, the water, as it goes up, this is a filter paper. As the water goes up, it carries a little bit of color along with it. And you can see that the black ink is actually not made with black ink, it is made with 3 colors. And these 3 colors travel at different distances on this paper. This technique is called as chromatography. Chromatography is used to separate mixtures. The length any particular color travels on the paper depends on the constituents of the color. It will depend on the porosity of the paper, and it will depend on the solvent. Here, as you can see, the colors are coming up, and the black ink actually separates into 3 constituent colors: the magenta, the yellow, and the blue. This is how it will look after the chromatography is completed. So now you can show that the crow was black. Crow, although it looks black now, it was rainbow colored long time ago. This is a very old paper folding story. You have to start with a square. This is the story of Bublu. Bublu is a boy who lives in city, and his grandparents live in countryside. In his summer vacations, Bublu decides to go visit his grandparents. So he travels in a train, goes to his grandparents, and then his grandparents live in a very beautiful, lovely house. And then Bublu sees that next to this house is a very beautiful lake. Bublu decides that if he has a boat, then it would be lovely to actually have a nice boat ride. So Bublu talks to his grandfather. His grandfather gives him some money and says that you can go to the marketplace and buy the kind of boat that you want. So Bublu takes the money from his grandfather and goes to a nearby market. The first shop that he sees in the market is that of selling a lot of kitchen goods. So the first thing he spots is a beautiful salt pepper box like this, and he decides to buy it for his grandmother. This is a beautiful salt pepper box that he buys for his grandmother. In the same shop, he sees another beautiful thing that he thinks would be a good addition to his grandma's kitchen, and that is a fruit basket. Since there are many fruit trees just outside his grandparents' home. So then he sees this fruit basket, and he decides to buy it for his grandparents as well. He buys these 2 things and is traveling along, and he suddenly sees a shop that sells ready-made garments. He realizes that winters tend to be very harsh in his grandma's village, and he decides to buy a sweater for his grandma. So he finds a sweater like this, which has nice collar and 2 long sleeves, and he buys a sweater for his grandma. He buys a sweater for grandma, and he buys a trouser for his grandpa. He takes these 2 things along, and he sees a hoarding saying that boats for sale. So he goes to this place which is selling boats, and he realizes the boats that this place has are steamboats. A boat like this that has 2 chimneys for funnels. He realizes that the lake that he has is very small, and this will be too much to buy. So he doesn't buy this board, and he again walks along the market and he sees a furniture shop. This shop has a lovely dining table. He realizes the dining table that his grandparents have has become a little old. So he decides to buy this dining table as well. Now dining table is very heavy. While he's lugging the table along, he gets very tired and thirsty. He's looking for water and he sees a windmill nearby. Wherever there is a windmill, there is going to be water. So Bublu drinks water near the windmill, and then he's looking around here and there, and again he sees a sign saying boats for sale. He goes there just to look at the kind of boats they have, and they have a twin boat like this. Bublu doesn't need a twin boat, so he sees if there is any other boat. Then he finds a sailboat there. Again, he doesn't want a sailboat either. He wants a simple boat that he can row. So he says he doesn't want any boats there. Now there is a farmer who is nearby, and the farmer has a very lovely, healthy looking rooster with him. So he says, why don't I buy a rooster for my grandparents so they have some company? So actually, and what happens is he doesn't want the table because it's too heavy. So he exchanges the table for a beautiful healthy rooster. So he buys this rooster. Now he doesn't have the table anymore because it's very heavy, and he has this rooster. Now Bublu realizes that, okay, I bought so many things, I should remember why I came here in the first place, and that is to buy a boat. So he first decides to check the amount of money that he has left. So he gets his purse out. Let me make a purse from here. So Bublu gets his purse out, and he realizes that he has just enough money still left to buy a few things. This is Bablu's purse. So he sees that he has enough money to buy a few more things. So it's been afternoon and it's very hot and sunny. So first he realizes that he needs to buy a cap. So he buys his beautiful baseball cap for himself, and then then as he is traveling in the market, he sees one photo frame shop. Bublu suddenly realizes that after his vacations are over, he would be going back to the city, and he is sure that his grandparents are going to miss him. So he goes to this photo shop and buys a lovely frame for his grandparents. Now Bublu says, enough is enough. I have bought so many things. Now the only thing that I am going to buy is the boat that I really need. So he goes to a nearby boat shop and finds a very beautiful boat like this. It's not only a very beautiful boat that he can sail, that he can row, but it has two beautiful backrests so that he can sit there along with his grandparents and have lovely time in the lake. Now this is also called as Chinese junk, and this is how Bublu lands up buying just the right boat he needs. This is Bablu's story. Now we have started this story with a square. Now let's see what are different things that we can do while exploring paper and square. Suppose you have a very irregular paper like this. How would you make a square from there? The fun part of paper is that whenever you fold paper into a crease, you get a straight line, right? It's 180 degrees. So you fold any paper that you have into a straight line like this, and fold it over. When you fold it over, you get 90 degrees, and you can also make a small crease so as to get a nice diagonal. You mark this diagonal from both sides and open it up. And now you can simply fold two sides here so as to get four corners of a square. Okay. Now you can simply make the creases at these points, and you get 4 points of a square. If you join all these points, You get a perfect square. So this is how you can make square out of any irregular shape. Now let's see how you can make a triangle out of a square. Suppose you have a square like this, and if you want to make a triangle, that is the largest equilateral triangle possible in this square. So let's see how to do it. First of all, I would fold it into half like this, open it up, and also fold it into the half from the other side. Now using this crease, I am going to fold this from here to here, and I will do a similar thing from the other side. Now I have 2 points of a square. Okay, so all 3 points actually of the triangle. Now I am going to fold this all the way up, right up to this middle line. You already have the diagonal here, and this is your triangle from a square. Now let's see, so we made a square, we made a triangle. Let's see how we can make a pentagon. For pentagon, all you need to get is to tie a knot in a strip. Suppose I have a strip like this, paper strip, and I tie a knot into this paper strip. You can get a very lovely pentagon. Suppose I cut it from here. You can see I can get a very regular pentagon like this. Using a pentagon, you can make many things. First of all, if you take a large enough pentagon, you can make a pentagon bird like this, or you can make a very beautiful gooseberry star. It's a nice puffed up star. Let me show you how to make it. If you have a strip like this, you simply have to tie a knot. Only get the knot on one side. All this is documented very well on arvindguptatoys.com, and we can share the links. And then you tuck the little strip inside and go on folding this strip until it's over along the sides of this pentagon. Now whatever the strip that remains, you simply have to tuck it in again and puff this star up by pinching on the sides. And this is your gooseberry star. So this is a pentagon. You can also learn a lot of fractions using a strip of paper like this. Now suppose this is a strip of paper that a farmer owns, and this strip of paper represents 2 by 2/3 acre. Suppose for some reason the farmer has to sell an acre of his land. How much of this paper would be 1 acre? That is the question. Now all of us know that 2 by 2/3 acre equals 8 by 3, right? So now if I divide this into 8 segments, if I fold it into 8 segments like this, 2, 4 and 8, 3 segments would be 1 acre. So if I have to sell 1 acre, 1, 2 and 3 segments, this much would be 1 acre. This much of it would be 1 acre. This would be second acre, and this remaining is 2/3 acre. So 1 plus 1 and 2/3. So this whole thing would be. You can also make a very lovely paper protractor if you just have a square piece. Let's see how to make it. First of all, you fold this square into half, and then you open it up, get this edge to the folded line, and this other side also you fold it along this edge and fold the bottom up. Now this is your triangle, and we are supposed to kind of look at all the angles that are made by this triangle. Let's see how. First of all, this is the corner of a square, so this is going to be 90 degrees. This is straight line divided into 3 equal angles, so this is going to be 60 degrees. If this is 90 and 60, since the angle of all the addition of all the angles in a triangle is going to be 180, this is going to be 30. This is double of 30 right here. This is double of 30. which is going to be 60 degrees here. This is 60 minus 90 minus 60, so this is going to be 30. This is half of 30, which is 15. This is again 90. So 90 and 15 again to add up to 180, this is going to be 75 degrees, and this whole thing is going to be 150 degrees. So all the angles in this protractor can be measured without using any equipment or instrument. This is the story of Krishna's birth. Probably all of us know it, that Krishna was born in captivity, in actually jail, to Vasudeva and Devaki. He was the 8th child, and before Krishna's birth, all 7 children were killed by Krishna's mama or uncle Kansa. So now Vasudeva and Devaki did not want their child to get hurt again. So now what Vasudeva does is, as soon as Krishna is born, he puts him in a bucket and carries him across the Yamuna river to his friend in Gokul. His name was Nanda and his wife Yashoda. And Nanda and Yashoda eventually raised Krishna. So let's see what happens when actually Krishna is born. Vasudeva, you can see the picture here. This is Vasudeva. Vasudeva is carrying Krishna in a basket, and then Vasudeva is crossing the Yamuna river. So this is Vasudeva, who is actually carrying Krishna on his head. And now as Vasudeva enters the Yamuna river, the Yamuna has a little bit of water. But soon Yamuna starts flooding and the water comes up to Vasudeva's waist. Then it comes to his chest, and eventually, as just about when Vasudeva is about to drown, Krishna's dangling foot touches the Yamuna river and the flood starts to recede. Let me get this picture out. Now let's see. Now this is actually an old plastic bottle, and this is a bendable crimped straw. So this has been, in this lid a crimped straw has been fixed. Now I am just going to push it in, and I am going to bend the straw, and it will go all the way in. Now as you know, for the siphon to begin, the water has to pass up the bend, only then the water will start draining out. So see, not yet, not yet, not yet. Only when it goes above the bend will the siphon start and the water will drain. So this is how you can tell Krishna's story. This is variation of the siphon. What happens is, right now if you suppose don't have a bent straw, how can you still start a siphon? How can you still drain this? So this is a simple straw which is fitted into the cap of this bottle, and if I fill this cup with water, the water will drain only up to the straw's top. Now just to start the siphon, what I have to do is, I have just taken a fat straw and closed it at one end, and if I push this really hard, the siphon should begin and the water starts to drain. This is a story of a generous and a greedy man. Once upon a time, there were two men, as I said, one generous and one greedy. An angel comes to earth one day and he wants to reward this generous man with some gift. So he gives this generous man a ticket, and he says that this is ticket to the heaven. When you go to the heaven, show this ticket to the guard and you will be able to enjoy all the luxuries of heaven. The greedy man who is standing behind is looking what this generous man has got as a gift. So as soon as the angel leaves, this greedy man comes to him and says that you are very generous, why don't you give me some part of your ticket. Generous man, and being generous, what he does is he cuts 1/3 of his ticket and gives it to the greedy man. The greedy man says that you are not being generous enough. You just gave me a small part of the ticket and large part of the ticket you have kept with you. Why don't you give me some more ticket? So the generous man, again being generous, he cuts a little bit more of the ticket and he gives it to the greedy man. Now the generous man has just 1/3 of the ticket left and the greedy man has 2/3. Now the greedy man is very in a hurry to go to the heaven. He goes to the heaven, he meets the guard there. The guard asks the greedy man for the ticket and he is very happy, he has the ticket, he gives him this ticket. Now the guard says, let me see what your ticket says. The guard slowly starts to open the ticket, and you know, as soon as he arranges his ticket, you know what he sees? He sees the word hell, and he says, no, you've come to the wrong place, your ticket spells hell and you need to go to hell. So now the greedy man goes out and the generous man now goes to the guard, and the guard again asks him, do you have the ticket to heaven? He says, yes, this is what I have. So now the guard again opens the ticket and he sees it's a cross, and the guard tells the generous man, welcome to heaven. This was the story. Now see how many things you can achieve with just a single cut. Let us explore a few possibilities. Suppose you have a square like this. I am just going to give all the squares similar folds. So I am first going to fold it into half and then into the next, and then this closed part I am going to fold it again into diagonals. Now if I cut it here, let us see what I get. These will be small parts, but if I open this, you get an eye. Suppose I take a similar square, but now instead of folding the closed part up, I am going to fold the other part like this, and suppose I cut it now. Let us see what we get. We get a shape like this. Now suppose I make a similar fold, but now I cut it in a different way. I get a cross like this. This is fun part of single cut geometry. It depends on how you fold, the results you get are going to be very different. Now let us explore something else. Suppose I have a triangle like this. This is any triangle. Suppose I want to cut this triangle in a single cut in one direction, in a straight line cut. What do we have to do? Let's see how, if I want to cut this triangle, what would you otherwise think? I would have to cut it thrice to get this triangle out of this paper. Now if I think that I need to cut it in one cut in a straight line, let's see what we have to do. First of all, we have to fold on the lines like this. This is my first fold, this is my second fold, and this is my third fold. Okay, so this is how I folded this triangle. Now we have to fold these triangles into halves so as to get angle bisectors here. The angle, all the angles we are going to bisect, and then you will see that the angle bisectors will meet at the in center. This is my second angle bisector, and this is my third angle bisector. Okay. Now I have got this point which is called as the in center of the triangle. Now I am going to open this fold again and fold on these lines, the incenters. I'm just going to get them up into ridges like this, straight line like this. Now suppose I cut into one long cut along this line. In a single cut, this triangle comes out. This is fun part of single cut geometry. Eric Demain is a mathematician who is very apt at doing this single cut geometry. He actually says that any straight line shape could be folded well and cut in a single line into the shape that we want. The ticket that we made was made using an A4 paper. A4 has a very unique proportion of its length and breadth, that is 1.414. Now, suppose you see a letter shaped paper, you can't figure out the ratio of the sides, but you still feel that it is slightly elongated. This proportion is a wonderful and aesthetic proportion, as we can say. There is a golden ratio as well, which is 1:1:1, and our body is also very proportionate. So if you start from just an A4 paper, you can make this very beautiful skeleton which is very proportional. ये कहानी है चंगू और मंगू नाम के दो लड़कों की. चंगू और मंगू दो देहात में रहने वाले लड़के हैं जिनका भी एग्जाम चल रहा है. जिस दिन उनका एग्जाम खत्म होता है, वो डिसाइड करते हैं कि आज हम गांव के बाहर घूमने चले. उनके गांव के बाहर 3 पहाड़ होते हैं. ये है हमारे चंगू और मंगू. तो वो डिसाइड करते हैं कि चलो पहाड़ पे चढ़ते हैं, और उनके एग्जाम खत्म होते होते शाम होती है, तो वो बहुत जल्दी करते हैं. तो 3 पहाड़ों पर चढ़ने का तो टाइम है नहीं, तो चंगू पहले एक पहाड़ पे चढ़ता है और नीचे उतरता है, फिर तीसरे पहाड़ पे चढ़ता है और फिर नीचे उतरता है. अभी मंगू बोलता है, अरे यार मुझे भी आना है आपके साथ. तो वो भी एक पहाड़ चढ़ता है, उतरता है और दूसरे पहाड़ पे चढ़ता है और चंगू को मिल जाता है. चंगू मंगू की और 2 दोस्त हैं जिनका नाम है चीकू और पीकू. अब तो काफी शाम हो गई है और चीकू और पीकू को तीनों पहाड़ या 2 भी पहाड़ चढ़ने का टाइम नहीं है. तो चीकू बोलता है कि मैं तो एक ही पहाड़ चढ़ूंगा. तो चीकू क्या करता है, एक पहाड़ चढ़ता है और चंगू मंगू को मिल जाता है. अब यहाँ हुए चंगू मंगू और चीकू. अभी क्या है कि पीकू को तो पहाड़ तक जाते जाते इतनी शाम हो जाती है, खुद को तीनों भी पहाड़ चढ़ने का टाइम नहीं है, तो वो एक साथ जाके चंगू और मंगू को मिल जाता है. यह है चंगू और मंगू की कहानी. अभी ये तो चालाकी है, इसमें कोई जादू नहीं है. अभी हम क्या करेंगे कि ट्रांसपेरेंट कप्स लेके ये कहानी आप अपने घर में कैसे कर सकते हैं वो दिखाती हूँ मैं आपको. एंड प्लीज रिमेंबर दैट व्हाइल शोइंग योर ट्रिक यू शुड नॉट बी यूजिंग ट्रांसपेरेंट कप्स, अदरवाइज people will know how you have done it. So as you guessed, I already started with Changu, Mangu, Chiku and Piku. Now let's see how to begin. First of all, you keep one this thing here, the second puff goes here, and the third cup will have both Changu and Mangu. So I said that Changu and Mangu are outside here. Now when I upturned the glass, there was already one puff under it. So now when I said that this guy goes up and comes down, there was already one here, and when I said this guy went up and down, there was already one Changu already there. Now Mangu has already joined, but you couldn't see it because the cup was paper cup. So now the Mangu climbed up, Mangu climbed down, Mangu climbed up again, and he met Changu. Now again Chiku was already here, but I said that Chiku is just going to climb one mountain and he will meet Changu Mangu. So this is what I did, that he came down. The last time Chiku, as I said, did not have time to climb any of the mountains, and he straight away went and met Changu Mangu and Chiku Piku. This is a lovely story. All of this was actually taught to us by a magician from Pune. Thanks to him for teaching us this, and I hope you enjoy performing it. There are many ways to tell a story. One of our friends, David Vale, he used to tell story of a very sad flamingo. Now this story had many animals in it. So what we tried to do is, we tried to extract peculiarities of that particular animal, and then we made a prop with it. Now this is a very sad flamingo. Here is our flamingo with his long neck and this is his flight. Okay, this is the flamingo. You can construct your own story. Now this flamingo is extremely sad because it lives in a swamp and his feet are always filled with mud. So the flamingo in our story is very sad. Now he has a very wise friend, a little frog. Now this frog, you know what frog does? Frog always hops and jumps. So this is made with a cardboard and a little stretchable rubber band inside. So if I press this flat and leave it, the frog will jump. So again I will show you again. So this is our frog. So the flamingo has a very wise frog friend. He says, why don't you travel across the world and see how the animals are behaving and whether they are happy at all. So the story goes that he goes to various continents and meets various animals, and then he sees that a lot of animals, although they have many hardships, they are still living happily. So when he comes back, he tells the frog that I know that people have some difficulties, but in spite of those difficulties they find some happy moments and live a joyous life. So in that story, suppose the flamingo went to Australia and Australia has a kangaroo. Kangaroo is also always jumping. So using these magnets whose opposite poles are close, I can make the kangaroo jump. This is a kangaroo that jumps, and press it and I release it. Since there is in opposing polarities, a kangaroo can jump. He also meets a crocodile in a swamp. A crocodile is made with a clamp, and then you can see it can open and close its mouth. It meets an elephant in the jungles. An elephant, if I pull its tail, is going to salute you. This is the elephant. And it also meets a giraffe with a long extending neck like this. So this is again a matchstick which we have stuck with the colors, and this is your extendable neck giraffe. Now you can tell the story with as many animals as you want. Just take the peculiarities of those animals and convert it into a nice prop. It is one thing to use a story and make some props and tell the story, and it's another thing to write your own story. You can also, there are various ways in which you can depict your story. Now this is a 14-page book that can be made with just 2 squares of papers, and it's cut and stuck in a way that it can make 14 different pages. So if you have a story in mind, you can divide it into 14 different pictures, draw these 14 pictures and have your own picture book. Like for example, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13 and 14. Again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13 and 14. So this is your own pocket illustrated story book. You can also make it into a flexagon like this. This is a 12-sided flexagon. 1, 2, 3, 4, 4, 5, 6, 8, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can divide your stories into 12 images and draw these images and make a flexagon like this. Again, this is also a circular model. So anything that is in cycles can be depicted like this. And this is your folding flexagon. One extremely pretty way of demonstrating a story is a matchbox story. Now this has been done by a very dear friend, and now you can see that this is a story. The name of the story is Paperboard. This matchbox just opens up and the drawer has this very beautifully illustrated story that goes like this. This is a very simple story of a girl who finds a paper, and since it is raining, she makes a boat and just slides it along the river stream that she finds. It's a very beautiful story. You can make your own collection of illustrated matchbox stories like this. You can give it as a gift and carry it as and when, wherever you go. This is your matchbox story. Another way to depict your story is to make a cylinder like this with a circular storyline. For example, this is a story of a girl who wants to go visit her grandma in her summer vacations. Now this is the road that has been drawn, and so she starts from a city. In city you see these skyscrapers and many buildings, and then she goes to a village like this and she travels on this road whatever she sees, many trees and jungles and a small, as you can see, a small temple here, then there is a bridge, and eventually she goes to her grandma's place. Now to show that, on a transparent sheet of paper we have stuck a car with this little girl sitting in the car. Now the car will slowly travel, the girl first will say bye bye to her friend, and she will slowly travel along this road. You have to move the car along this road. So while you stay, it's a beautiful story where you can actually talk about these pictures. So what is there in a city? There are many industries, there are many houses, then she passes a river, there is a bridge on the river, this is a scarecrow, and eventually she comes, there is a temple that she passes, this is a scarecrow, and she eventually comes and meets her grandma. This is also a way of depicting a story. Another way to do it is write your own book, and this is a nice way to actually bind your book. I will show you this. So these are pages, you can edit this and you can change the number of pages like this. This is your cover, it actually just passes. So these pages would pass through the notches in the cover, and you simply have to put a broomstick or something like that will hold it in place, and this is your own book where you can write your stories and add or delete pages as and when you want. In a few days it is going to be Diwali, and let me show you 3 simple toys that make nice sound for your Diwali. This is your Diwali Fataka. These are 2 cardboards that have a notch in the middle. I am just going to attach a rubber band here. The way to play with this Fataka is that you simply open it up and double up like this, so that your rubber band is stretched, and the moment I release it, it makes a nice Fataka sound. I will show you again. You just open it up and double like this and release into a Fataka. Another way to do it is that these are 2 A4 strips. You simply have to, they are about 1.5 inches in width. You simply double up like this and then fold it one more time. We used to play with this when we were young using canary leaves, but now you can also do it with an A4. Now you simply have to clap it so that it makes nice Fataka sound, and if you release your hand, can make a nice Fataka sound. Show you again. Or simply clap it. Another way to have a nice Fataka sound is take some thin paper, not a thick one, roll it up maybe 5 or 6 times, then double up like this, and then get the folded edge up and hold this like this, and you just flick it down and it makes a Fataka sound. So I will show you again. Just fold it, roll it, get this up and flick it. These are 3 toys that you can make for your Diwali. Storytelling is fundamental part of being human. Stories are fun, they are magical, and they connect. If you have props in your hand while you are telling stories, it can get even a mundane story to become very exciting and amazing. So read and listen to as many stories as you can. They could be fantasy, it could be science fiction, it could be some biography, it could be a travelogue. So read as many stories as you can and tell them. Storytelling is beneficial to both the listener and storyteller alike. Writing your own stories again is very good. So please write your own stories as well, depict them in many forms, use a prop and go storytelling. Thank you very much for listening to me very patiently. Also wish you again a happy Children's Day and a very happy and safe Diwali. Thank you.